This conference will now be recorded.
Good morning, friends. Welcome to GoOnlineTrainings.com. So, yesterday we had seen part one of indexes, where we were talking about how many indexes we have and what is a clustered index and what is a non-clustered index. We just introduced, but really we did not speak about them. So today, let us talk about what is a clustered index and what is a non-clustered index. And we had discussed about when the indexes are good. So indexes are good if you wanted to retrieve the data or if you wanted to retrieve the data randomly. But when indexes is bad, when you wanted to write the data, so definitely indexes are bad. Okay. So when you have OLTP system, definitely you need to reduce the number of indexes, but you cannot say I'll have zero indexes. Okay. So you need to reduce the number of indexes. And when you have OLAP system or data warehousing system, where you will read more and more, or data retrieval than the uh, data writing, because once in a year, once in a quarter, once in a month, or once in a week, you will be able to dumping the data into the data warehouse with the help of ETL, right? So writing is very very slow or low there, and reading is must be very very faster. So many data warehousing applications must be having more and more indexes. Clear? So those are the things we discussed yesterday. Now, we were also discussing about modes of the data storage. Random data storage is heaping. Heaping means it doesn't have any kind of a structure. Data is not sorted in the internally, in the data pages. But when you create a clustered index, what happens is that ordered the data storage order by the key value. Okay, so 1 1 3 3 5 something like this. So the data physically, try to understand, it is not logical. Physically, it goes to the data page, goes to arrange the data physically in the data pages in the MDF uh, MDF file, and it also create a index page physically, and plus it's going to be organizing the data over there, and you will have index pages and the data pages will sit together in your MDF file. So this is your MDF file. So you have first, second, third maybe index pages, and 4 5 6 7, these are called data pages. Okay, these are the types of the pages in MDF you have. So whenever you buy a book, the table of content is nothing but the indexing pages. And when you have a chapter, sub chapter 1, chapter 2, those are called data pages. Clear? So index is a physical page. It is not a logical, and the data has to be organized first. So without organizing the data, without sorting the data, you will not be able to create an index. Clear? So that is what is very important in terms of clustered index. Okay. So clustered index definitely is going to be sorting the data. That is what we had seen yesterday. So I was talking about a table scanning. When the data is not, there properly, if there is no index is happening, whenever I, retrieve some kind of a query, okay, when I say select star from, employee table, and where, employee ID equals to, let us say, some number like this. If I don't have proper indexing mechanism, so I don't know where to start. So SQL Server will take row by row, row by row. So it will go, is it 3827? No. Is it 3827? It is going to be verifying from first row to last row. When it is verifying row by row, row by row, row by row, row by row, so that is what is called a table scanning. The table scanning means it is very very slow operation. It is reading from first row to last row, row by row. It doesn't have any clue where the data for this query. Clear? So it will take a lot of time. So it will take a lot of time. So table, it is a table scanning. So table scanning also we discussed already. Clear? Table scanning is very very slow operation. When there is a slow operation, definitely people cannot wait to retrieve their balance. For example, you go to the bank, you would like to retrieve what is my balance. If you have 1 million customers in the bank, if the SQL Server or Oracle is reading row by row, row by row, is it your bank account number or not? It is reading like that. It is very, very difficult for the customers to wait that much of a time, then they will hate the application, they'll come out. So you don't wait more than 3 to 4 seconds to get your balance, right? It is very, very difficult. So index has to be created to give that kind of a quick response at the time of reading the data. Am I clear? So definitely table scanning is very, very slow operation. But now sometimes people would ask you when index is bad. Okay, when index is bad, so I told you when you wanted to write the data. The answer is what? When we wanted to write the data. Okay, write the data, definitely indexes are bad. Okay, the next question people are going to be asking, even though there is an index, when does SQL Server or Oracle SQL Server, when does SQL Server not use an index, even though there is an index available? But tell me some scenarios when the SQL Server is not going to use the indexes. First, I would like to read full data. Okay, for example, I say select star from employee table. So are we going to use any indexes? Because select star from employee means what is the meaning? I need all the data from the employee table. When you need all the data from the employee table, is there any indexes used? Even though a lot of indexes are available, no, you wanted to read complete data. If you wanted to read complete data, then what happens is that table scanning is used. When does SQL Server not use any kind of an index? Because when you wanted to read all the data. Okay, so when when we read all the data, that means if you wanted to read data randomly, for example, what is my balance? I'm focusing on one row or set of rows. That time only the indexes are useful. But if you wanted to read, a complete, data, definitely indexes are bad. So you have seen lot of magazines, right? So magazines will have indexes because you can go to any chapter anytime. But when you buy a novel, so there is no index over there. Have you seen any novel? Because when you open the novel, you need to read from first page to last page. You cannot go, in between and say, I would like to read the middle chapter first, because you don't understand the story. So novels does not have any index, only one thing, because you have to read the complete data. If anybody wanted to read complete novel, so that time index is not going to help. Clear? So hence the novels are not going to be having any index. But when you buy any magazine, because magazine will have collection of stories, I would like to read some story, then you can go for the indexing number, read only that story and come out. Clear? Novels will not have any indexes, because if you don't read complete to 100 200 pages, you don't understand the story at all. Clear? The best example is novel. When we wanted to read all the data, then this is one case where the indexes are not useful. The second case, let me talk about now. The second case is that when the table size is small, when the table size is small, the indexes are not useful. Okay, so for example, I have only 1,000 or 10,000 rows in my table. Okay, and plus I have a lot of indexes got created on that, even though there is a index pages and everything is there. But since it is a small table, the SQL Server is not going to be using indexes. It is going to be using a table scanning only. Clear? For example, when the data size is very, very small, even though you create an index on that, SQL Server is not going to use index. For example, you have 3 2 pages small book is there. Okay, so you wanted to verify what is Brazil's currency. There is a currency printed, country and currency. Okay, you would like to see at least 1 or 2 pages is available there. That's it. But will you create an index page? No, you will not. Simply you'll go to the first page and turn around and see the second page. Now you can find out where is the Brazil, what is the Brazil's currency. So when you have a small set of data, even you don't any index, you flip here and there, you should be able to find out the data. Clear? Even though there is index for that, will you use it? No, you're not going to be using it, right? You have chapter 1 and chapter 2 in your book, small book, and you would like to verify where is the chapter one? So directly you'll go to the data pages and scan it. So never, then nobody will is going to be using the index and jump to the data pages. Clear? So these are the things that you need to index. Okay. When does SQL Server not use an index? When we read all the data. Second one is that when the table size is small. Third one is that when there is no index in the pages and the data in the index on the table. So this is also one more choice. For example, you don't have indexes. That means the data is in heap structure. Okay. If that is the case, SQL Server is not going to do anything. SQL Server is going to be using only the index scanning. So people may ask you a question, when does SQL Server not use an index, or when SQL will perform table scanning? People may ask you either that or this. When SQL Server will perform in table scanning instead of indexes, you can tell them that these are the few reasons where the SQL Server is going to be doing. When we read all the data, when that table size is small, when there is no index on the table, in three cases SQL Server is going to be using the table scanning only. So what do you mean by table scanning? Reading the row by row, row by row, row by row until you reach the all rows are required. That is what is called table scanning. Table scanning is very, very slow operation. Because of that, you have to be creating appropriate indexes. Now, yesterday we know that SQL Server is going to be having two types of indexes. So I told you types of indexes in SQL Server. One index is called clustered index. That's what we discussed yesterday. Okay. So when you create a clustered index, what happens when you create a non-clustered index also we have to know. Okay, so SQL Server will have two types of indexes. The first index is called clustered index. The second index is called non-clustered index. Let us talk about clustered index. Clustered index will be created when we create, okay, when we create a primary key, automatically clustered index will be created on the table. Okay, so the second point is that so only one clustered index per table. Okay, so this is the second point that you need to understand. Per table we can have only one clustered index on the table. The next point is that it is going to be sorting the data by default ascending, but if you wanted to make descending, that you can do it. Then what happens is that index pages are created internally. Clear? So data going to be sorted and index pages are created so that it is going to be using the data. So we can have only one clustered index, not more than that. Okay, so now that is what is the important point that we need to understand. So how the clustered index is going to be organizing data access with the table scan. Data in earlier part of the page is retrieval fast. Data later part, or retrieved slow. Table scanning is the good one. So for small tables, it will be good. Table scanning is good for the small tables or when you don't have, index. And if you wanted to read all the data, so this is very, very good. Need for indexes, speed up retrieval of data instead of table scanning depends on the query made. How you're writing the query depends on that. It's going to be using the index. Give choices to the query optimizer. So query optimizer means we're talking about the SQL Server. So how is that I should be able to go and execute the query? Okay, if there is an index plan, the query optimizer is nothing but a small piece of code. So how I should go internally and fetch the data? Should I use row by row, or do you have any index? Based on that, I can plan and retrieve the data. So that is what you are giving the choice to the SQL Server engine. So indexing criteria, should data be present in the specific order in the table? So that is what is the that you need to worry about it. How many columns to index, and what impact on hard disk space and DML operations and performance. Okay, do I read a lot of data? Do I or do lot of updations, insertion, deletions? And if you create an index space, the definitely indexes is also going to occupy a lot of pages. So that is also one more impact in the MDF file, because when you have 10 million row, 20 million data, terabytes of data, when you have it, definitely to create index page, it is going to be occupying a lot of hard disk space. That is also important. Okay, DML operation means I'm talking about reading and writing and performance. What is that you would like to improve, and what is that you're not going to improve the performance. So all these things you need to understand. Now, index types, so clustered index determines the physical storage of the data in a table, only one per table. One or more columns we can include, create a that one, and we can go for the second index, non-clustered index, maximum 999 per table, one or more columns you can put it there. Now, when you go in for the clustered index, the organization is like that. For example, I have created, this is my data. Okay, so this is my heap structure we were talking about. Now later what we had done, we had organized the data like this. Okay, so you take, and all the data is available. Let me copy this data first here. And when you create a clustered index, what happens is that on this column, when you create a primary key on this, automatically the data is going to be, it is going to be sorted in the alphabetical order by default ascending order. Okay, now let me take this in Excel sheet. We simply go here and we sort the data like this. Okay, physically SQL Server is also going to be sorting the data when you create a clustered index. When did we create a clustered index? We never create a clustered index. We simply created what is called as a primary key. That's it. When you create a primary key on this column, internally Microsoft is going to be creating a clustered index in it. Clustered index means it is going to be sorting the data completely. It is going to be ordering the data internally, physically here. So it gets all the data to the temp DB. It is going to be sorting and reordering the data. That's what you need to understand. So organizing the data, then create an index page. Now, how the index page would be created? Now, you will have one root node. Okay, so clustered index architecture I'm talking about. Now, when you create a clustered index, we are not creating, when you create a primary key automatically. So this is how the clustered index is going to be internally creating an architecture. Okay, B tree architecture, people will say clustered index architecture. Okay, so you have a root node or root page. Okay, so here it will give you uh, row number 1 to, let us say, 1 to 100. Okay, it is available in the page numbers. Okay, now here I'm going to be talking about the rows, and here I'm going to be having a page number. Okay, so that is what you need to understand here. Okay, now 100 and 1 to 200 is available in page number 2. Okay, sorry, not 101, 101 to 200. Now 2012, let us say 300 is available in the page number 3. That is how the root node is going to be containing some information. Okay, so here the page numbers and rows. Okay, so from 1 to 100, 101 to 200, something like this. Then later you will be having intermediate pages. Okay, so now this is, some of them pages are available intermediately, and here the pages are going to be having like this. Okay, now a lot of intermediate pages are available here. Now here it says that now row number 1 to 10, row number 1 to 10, okay, available in page number 1. 11 to 22 available in page number 2. Okay, like that it is going to be organizing the data. So the complete data 1 to 100 is completely available. So 90 to 100 is available also here. Okay, so some page number, some nth page. So this is what is called page number. Every page will have a numbers, page number 1, page number 2, page number 3. Some page numbers will be available there. Okay, page number 3, page number 4, something like this. Okay, now in the second page it has to start with 101. Okay, 101, 1 to 10 rows, 110. So this is available in some page number 34, something like this. The data will be available there. So there is a row number 1 to 10, 11 to 20, not 22, okay? 11 to 20 and 21 to 30, like something like this. You're going to be having the pages. Now, this is a root node. This is intermediate nodes. Okay, these are called intermediate pages. Intermediate nodes or pages. Now, when you come down, what happens is that it is going to be organizing. Okay. Now, let me take some more space. Now, what is going to be happening? So, internally, you will have this page is linked up to some more pages. This page is linked up to some more pages. Okay, like that, you will be able to have some more pages here. Okay. Now, you may have some lot of pages got created where you should be able to store your data physically in your clustered index leaf node. So here you have a page here. Okay. Now actual physical data is going to be stored. Okay. Now let me delete this. Now, how is the data? For example, I have this one. So in the first page, I should be able to organize 1 to 10 rows. Okay. Actually, I have, data like this, 1, 2, 3, 4, continuously I have data. This data will go to the page number 1. So page number 1 is, so this data is going to be occupying and going to go here. So actually the physical data is going to be coming here, this and this. Okay. The second page, okay, sorry. Okay, the second page data, the first page data is going to be occupying in the first page. Then you have a second page, then you have a third page. A lot of things is going to be occupying. For example, now I wanted to know what is my, let me write a query. Select star from employee table where employee ID equals to 8. Okay. So I don't know where the 8 is. First, I will go to the root page. SQL Server is going to be routing page. So 8, will it be between 1 to 100 or 101 to 200? So it is going to be reading this data. So 1 to 100. So when you say 8, 8 is between 1 to 100. So it is going to be jumping to page number 1. Okay. So when it's going to be going to page number 1, then it is saying 8 is between 1 to 10. Okay, it is between 1 to 10. So it will take the page number, then it is going to be pointing to page number here. Okay, so now here it is going to be scanning this page because you have 10, some 10, 20 rows. I can easily go there and is it 8? Is it 8? It's going to be scanning and getting the data. So maximum reads are 1, 2, and 3. Okay, maximum reads you need to waste. So first you have to go here, and second you need to jump here. Third you need to jump here. So maximum reads will waste, but 1 or 2 reads you should be able to get the data. But instead of that, you have a data like this. Let us think that you have a data. Okay, I have lot many data is organized in the heap manner. I don't know where the required data I have. For example, let me put some data. I have 12 here. I have 5 here. I have 33 here. I have 7 there. I have 11 here. I have 20 there. Okay. I have 77 here. I have 6 there. Okay. And I have a 8 here. So that is the data is not in the a structured manner. Now I would like to find out the eighth. So the simple question is that find out 8. When somebody says find out 8, you don't know where the 8 is. So you have to waste lot of reads. First you need to read this. Is it 8? No. 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 Is it 8? Yes. That means how many reads you have wasted? You have wasted 1, 2, 3, 4, 5, 6, 7, 8. 8 reads you have wasted. Then finally you got the 8. So that means what? When the data is not organized, okay, properly, and when you don't have the index, fortunate that you have wasted only the eight reads. But when you have millions of data, you have to waste millions of reads, because in the table scanning, that is how the things would happen. But when you go for the index page, if you need any kind of a data, so how many reads are going to be wasting? So you need to hit one page. Is it under this? Okay, now I'll be going to the appropriate page. From there you will be jumping to the data pages. Now here there is an index page, and this is also an index page, and this is what is called the leaf node, the bottom pages. Leaf nodes, what are the things? Leaf nodes are nothing but actual data pages only. The data is going to be organized like this. Then you have second page. Okay, because we clearly told 1 to 10 rows have to be there in the first page. Then 11 to 20 pages have to be there in the second page, and 11 to this one has to be there in the third page. Something like this, the data will get organized. Clear? So it will not keep any blank pages, otherwise it is going to be distributing. So 1 to, it'll put like this, 1 to 150 page number 1, something like this. It is going to be organizing. Then or 1 to 100 pages, because the total pages are I have, total rows I have 1 2 3 4 5 6 7. It will put 1 to till 350 rows, or 1 to 400 rows are available in page number 1. So it is going to be organizing the data like that. But when you have continuously data, it is going to be organizing like this. Okay, now the leaf node is going to be having the complete data. Complete data. So however you're able to see the data in the table, all the data is going to be organized physically in the bottom of the pages. Now always you jump here, you read, not you, SQL Server is going to be going to the root node and finding appropriate the page numbers. From there they'll be jumping into this page. From here it is going to be jumping to the root node and getting a lot of data. Tomorrow you may have this rows may be copied into the second page, something like this. You will be having the data to the second page. Now let me go and put the, sorry, let me put the second page data as well here. So like that, this is the page number 1, this may be page number 2. Like that you will have a lot of things. Then you have some more data pages. Okay, so where you will be able to get some more data also here. For example, all this remaining data is placed onto some other page. So everything is placed, organized, and data is physically sorted. Okay, try to understand, but divided into multiple pages. Clear? So the data internally, it is going to be organized. So people would ask you, what is the clustered index architecture? So clustered index architecture would be like this. So you have a root node, and you have a intermediate node, and you have a leaf node, so that you should be able to easily come to the appropriate pages. Now this architecture is called as a when you drive a car with a gears. Okay, so how the gear architecture? So there is a neutral here. Okay, there is a neutral here. And now what is going to be happening? You have gear number 1, gear number 2, gear number 3, gear number 4. So why the architecture is like this? Because you can easily come to any gear any point of time, right? So 2, and you have a 3, and you have a 4. Okay, for example, I would like to, I'm in the second gear, I would like to go for the fourth gear. So how many reads I have to waste? From the second gear I have to go to the neutral, and from the neutral I have to go. So only one read I have to waste it. For example, I am in the first gear. If I wanted to go to the second gear, from first gear you need to go and jump here. Okay, so maximum 1, that is neutral, then second gear 1. From 1 I would like to jump to 3. From 1 I have to go here and go to this. So you're wasting. From 1 I have to go to the fourth row. So 1 you have to come to the neutral, and you have to go to the fourth row. So this is what, anytime you're wasting only one gear. But let us talk about the gears are organized like this. Bike gears 1, 2, 3, and 4. For example, so the gears in the bike is like this. I am in the first gear, and I would like to go to the fourth gear. So how do I come? So I have to go first, second, and third, and four. Are you taking? When the gears are organized like that, if you wanted to come to the fourth gear, you have to waste a lot of gears. So you need to go to first gear. So you're in this gear and go to the second gear, right? Then you go to the next gear and you would reach this. But if you have 10 gears, then you need to keep on wasting 1, 2, 3, 4, 5, 6, 7, 8. Then you reach 10. But when you organize the data like this, just like a car gears, this is the one structure of the data. So this is what is called, I'm telling, a clustered. Clustered means from any to anywhere, with the minimal wastage, we should be able to jump it. Okay, from here we should be able to jump with minimum, or reads. So when you go for the bike gears are nothing but a table scanning. You need to waste lot of readings to reach the fourth gear. But bike gears, when you have a first gear, from here you can go to any gear without wasting your another gears. From one you can go to the fourth, but from one here you will not be able to go to fourth because sequentially the data is organized like that. So this is how the internally the clustered index is going to be organizing the data. Am I clear? But now, if I say select star from employee where employee ID equals to 8, the data is organized on the employee number so that I should be able to fetch the data. But tomorrow, what happens is that the customers are going to be asking like this. I would like to know select star from employee table where city equals to Hyderabad. Okay, city equals to HYD. When you write the data like this, now in your leaf nodes you have Hyderabad, Bangalore, Bangalore, Chennai, Chennai, Hyderabad, Hyderabad, like that. So this, already you have created an index on the employee ID. So on this you have created, and this is what is called index. But this query is going to be, performing very, very quickly, but this query not at all performing quickly because I have to get the data based on the Hyderabad. I cannot get the data based on what, based on the, employee number. So when the column changes in the where clause, even though you have created index on the employee ID, that's not going to be useful to you because this query is fantastically going to be working. But here, this query cannot use this index at all. So this index is on only the employee number. So whenever you use employee ID equals to 8, or whenever you say employee ID greater than 8, less than 8, between 1 and 10, so a lot of things are good. So or not equals to 8, employee ID not equals to 8, lot of things you can use, but purely on the employee ID column. But tomorrow I may be writing the data based on the city also, but on the city column you don't have any index, and existing index is not sufficient to go to the you know to get the data from the city column. So this is not, it's going to be using a table scanning again. So it will go row by row. It is Hyderabad, is it Hyderabad, is it Hyderabad, is it Hyderabad? It's going to be, even though index page is available, but the index is not useful for the city column. So that is when I have to switch from the clustered index to the non-clustered index, because we know that we can create only one clustered index, but I need one more index to be created. But clustered index only we can have only one. I cannot go in for the second clustered index. When Microsoft is giving you, you can create for non-clustered index. So one more non-clustered index gets created on a column called city column. Okay, so that is the point why we need to go in for the non-clustered index. So clustered index will be happening only one column. So on that column, if you have a query, that index will be faster. But when you change the query, on that column also you need to create one more non-clustered index. So that is one thing you need to create. So clustered index, when you create a primary key, it will happen. Thus, next question is, we can also create a clustered index manually also you should be able to create. create index manually, so there is no issue at all. So there is a syntax called create index. Okay, so you can say create clustered. Okay, create a clustered index, then you need to write the index name. Okay, index name, then you need to put the table name and column name. Okay, on you have to, table name you need to give, and the column name also you need to specify on which column you should be able to create. Okay, something like this. You will have a create a clustered index. For example, I don't have a primary key, so that means a table does not have an index, any kind of an index. That means people may ask you, I did not create any primary key, but I would like to create a clustered index manually. Is there any syntax? The answer is yes, there is a syntax. You can go in for create a clustered index name on a table name. What is the column that you need to give? So it's going to be creating an index. So index is there, but inside that I don't have a primary key. Primary key means it is going to be verifying the duplicates. That's it, nothing else. Okay, so that is what is the point here. So create a clustered index also should be possible, but one index is not useful, so you need to go in for much more indexes. So you can have one clustered index, and remaining, if you want to create, you can have much more non-clustered indexes. Now I have to switch from clustered index to non-clustered indexes. This is why you need to go in for one more index in your table. Clear? So when you go for one more non-clustered indexes, now the first question is that when we create a unique keys, so automatically when we create a primary key, clustered index gets created like that. When we create a unique key, automatically non-clustered index gets created, because you can have many unique keys per table. You can automatically, it is creating on in each and every column one non-clustered index. Okay, that that architecture also I'm going to be showing. So only one clustered, but you can have a total triple nine non-clustered indexes we can have per table. Clear? And it is not going to be sorting any data, because data already been sorted with the clustered index. It is simply create an index page, no sorting, nothing. It creates. Okay, it creates an index pages. It creates lots of index. It creates index pages. That's it, and store them. So index pages will be created, and it is going to be store them. And the next point is that we can also create them in manually. So that's it. So simply you can go here. So the same syntax you have to use it here, but only thing you have to remove the clustered. That's it. When you remove the clustered, when you simply say index, it is a non-clustered. Only for the clustered you need to say clustered. That's it. Okay, so create index name on the table name. When you say column name, it is by default non-clustered index, but only for the non-clustered index we have to put clustered. That's it. That is this one, on which column you would like to create. For example, I would like to create on the employee table. So what you do, I am not creating any primary key or unique key. Simply I would like to create, so index name is, let us say, index 1. Okay, and on what table I would like to create, my table name is employee. Now what column I would like to use, the column name is called city. That's it. It's going to be creating an index on this column. Okay, so if you wanted to see the index, then there is a help index. Okay, and you need to give the table name. So to read the indexes, we can see like this. Read the index from a table means you should be able to read sp underscore help index employee name. So employee is the table name. So the table you need to use it, so that you will be able to get all the indexes on this table. That's it. So this is how you should be able to create. Now I've created one index on the city. Now how the things would happen. So this is already one index available. The data is organized like this, but the data physically it is going to be stored like this. But you need to understand, this is the root node, then you have intermediate nodes are here, then you have a leaf nodes are here. Everything is next to each other only, but understanding purpose I have written like this. Clear? So in the MDF pages only, continuously you will have a root node. SQL Server will always visit the index root node. Then from there, the next point would be the leaf node. From there, it will go to the data pages here. Clear? So organization will be like this only, but we need to understand diagrammatically like this. It will give you a proper picture. Picture. So it is everything will have a page number. Page number 1 is a root node. Okay. Then you have page number 2, 3, 4 are intermediate nodes. Then you have 5, 6, 7 onwards. Maybe it is data pages. Clear? In the clustered index, you will have the index pages followed by the data pages. Okay, but when you create a non-clustered index, what happens? Let us see. For example, I'm going to be creating a non-clustered index down. Okay. Now I would like to create a non-clustered index here. So what happens is that here one more index gets created. Okay, this is non-clustered index architecture I'm talking about. So I would like to create on the non-clustered index architecture. First, whatever be the cities you have on the city column, I'm taking right. We have cities called Hyderabad, Bangalore, Chennai. So it is going to be taking the distinct cities and it's going to be organizing. Okay. So let me put Bangalore. Okay. Now it says at page number 1. Then second one is Hyderabad and page number 2. Then next one is called, you have a Chennai. Okay. Chennai is available in page number 2 and page number 3. It is going to be organizing all the data like this. Now, later it is going to be having a data like this. Now, I'm going to be verifying the page number 1 is going to be, having what is called a page number here and there is a row number here. Okay, this is how the data will be organized. So now what it is going to be doing, I would like to read the Bangalore data. So what it goes here. So where is the Bangalore data is available? Bangalore data is available in the page number 1 because this is Bangalore data. Have you seen? So it will write Bangalore data is available in page number 1 and row number 2. So what happens is that, so this is, first row, this is the second row. So first row, every row will have a row numbers here. Okay, this is row number 1, row number 2, row number 3, row number 4, like that. Row number will be there and it is a page number. So in this page also you have a page number and you have a row number also. Now, I would like to get only the Bangalore data. Bangalore data is here. Bangalore data is here and Bangalore data is not there. So it says that page number 1, row number 2, page number 1, row number 2, and again page number 2. Okay, page number 2 and row number 1 where the Bangalore data is available. It's going to be creating like this. Okay, now for the Chennai also it is creating one more index page. This is the index page. Now here it's going to be organizing. Okay, this is index page number 2. Now where the Chennai is available not in the first page. Chennai is available in the next page. Okay, now let me take in different color. So this is one record and this is one more record and that's it. Okay, now what happens here? Chennai is available. Let me write here page number and I will have a row number. In the page number 2, row number I think 1 and in a page number 3 and row number I think 2, right? So something like this. Page number 2 and 2, sorry, 2 and 2 and 3 and 1. So here I have to say 2 and 2. Okay, and page number 3 and this is 1. Are you getting the point or not? So this is how the data would be organized. If somebody asks you, select star from, select star from employee where city equals to Hyderabad. So this is the query they had given. SQL Server immediately will be pointing, will be checking, is there any index on the city column? Yes, there is index. So it will go to this clustered index. Now it is going to be verifying, is it Bangalore? No. Is it Bangalore? Is it Hyderabad? What is that I would like to verify? I would like to verify on the employee city equals to Hyderabad. The first reading is that it is going to be pointing to Hyderabad. From here, from Hyderabad, it is going to be jumping to the page number 1 or 3, and from there, for example, it would like to get page number, the city equals to Chennai. So from the Chennai, it is going to be pointing to this. Then after that, it is going to be reading all the data from these pages. Okay, these rows are completely Chennai rows. Okay, these are called pointers to this. Pointer means address. So you think that this row is pointing, this row is pointing, when you see this is pointing to this row. Okay, this pointing to this row. Okay, now the second row is pointing page number 2. This is pointing page number, because I need, Chennai data, Bangalore data, whatever you would like to point, that will be pointing to, this is page number 2 1, page number 2 and 1, this is pointing to this. Okay, so non-clustered index is going to be having, so address to the, this is address means what is the page number, what is the row number. It is going to be having addresses to the a clustered index pages. Clear? It is pointing to the address to the clustered index pages. Like that, you can create also one more non-clustered index on the city column. You may have date of birth column, you may have, gender column, you may have a phone number column. So I like that, employee ID, employee name, employee gender, employee date of birth, employee city, employee company, employee address. Lot of columns are available. It is going to be creating one more index page and storing the addresses of the, the actual row in your non-clustered indexes, now which is going to be pointing to the clustered index. This is the clustered index, and the clustered index leaf nodes, the non-clustered indexes are going to be pointing to. This is very, very important point that people would tell you. Okay, so you have a clustered index will have a root node, intermediate node, leaf node. These are pages. And when you create a non-clustered index, what happens is that these pages are completely pointing to them. Clear? So that is how you need to understand. So you can create a lot many indexes like that, and it will give you lot of data. So whenever you need the data, it is going to be taking one of the index page, and these pages are again physically stored into here only. So you have a normal, clustered index pages, and you will have a non-clustered index pages also will be there. So when you buy a book, there is a table of content, but when you go to the end of the book, they will be giving a word by word. Word start with A, there is an index. Word start with B, there is an index. Have you seen? So there is a word by word index is given. So based on that also, sometime we would like to go and, jump the chapter. You will have a lot many index can be created. So physical pages are created, and index pages are created, and these are pointing to the data pages. So that is what you need to understand when we're talking about, so clustered and non-clustered. Okay, in tomorrow's class we'll be discussing about what is a covered index, and when should I use clustered index, when should I use non-clustered index, and all of them we're going to be discussing tomorrow in tomorrow's index class. Am I clear? So what is the clustered, what is the non-clustered, we had seen today, and tomorrow we'll be planning some more.